Let me introduce you the hospital itself that I worked on back in 2008, 2009, and walk you through this hospital as a case study. So the owner of the hospital is St. Joseph Health System. They are all around in California. The building itself was located in Fullerton, California, and it was an expansion to the already existing medical plaza, St. Jude Medical Plaza. The floor area is 98,000 gross foot. It was located on 4 stories. As a medical plaza, it has all the different functions in the building, not only hospital functions, but also office spaces, administrative offices, and the surgery centers on the top floor and on the first floor, as well as imaging services and patient care rooms. We not only worked on in-wall coordination on this project, but we're also involved in our standard 4D, 5D services, as well as provided structural and architectural background for above head coordination, so participated in MEP coordination, and we did our constructability analysis. After introducing the building itself, let's talk a few minutes about what in-wall coordination really means. I think the term in-wall coordination is rather self-explaining, so I don't think that we have to make up more complex definitions for this. In-wall coordination is simply placing and coordinating everything, as Halim already mentioned, everything which is in the wall, what is located on the surface of the wall, and what stands or mounted in front of the wall. If you want to see some examples, for example, for the partition, what the partition walls contain inside, we can think of the structure of the partition wall itself, so the metal studs that hold the partition. Or if we want to place, for example, heavier casework on the partition wall, we obviously need some backing system for that, that you can see on this next image in red. So those backing systems are holding the heavy casework. But we obviously also have some piping routed in the partition walls. In normal or standard cases, in standard building types, it is most likely domestic water based or mechanical piping. But in case of a hospital or in case of a medical building, you could also find medical piping, medical gases, and all the different kind of systems. You also have some small pieces of equipment, some elements placed on the surface of the wall. However, it definitely requires some supply system which is placed or routed in the inside of the wall. So if you think of data outlets, power outlets, switches, receptacles, fire alarms, those are mounted on the surface of the wall. However, obviously need some pretty complex conduit system behind it. So obviously requires space as well to place the junction boxes and to get from A to B in terms of outlets. Let's see a couple of examples for what we can place on the surface of the partition walls. And as my case study is a medical building, I will show you a couple of examples for such medical equipment. Let's start with the first one. I think it's familiar for all of us. It's a hand sanitizer. We can even find them in supermarkets all around the place. And it doesn't seem to be a big deal to place it on the wall. No one would really think that it has to be coordinated. However, if you think of a medical building, if you think of a patient room, you can be sure that the nurses and the doctors who enter the room would want to touch such a piece of equipment for the first time. So this would be the first thing that they touch when they enter the room, and also it would be the last thing that they touch and use when they exit the room. So it's quite important to locate it in the right location, in the right place, and it will drive and it will define the location of other pieces of equipment which maybe require supply and maybe require some routing in the partition wall. So it is really important to locate it on the right location. The other screenshot or the other image is not too complicated either. It's a drinking fountain, but it is quite heavy. So the previously shown backing is really required in case of such a drinking fountain, as well as electrical and domestic water supply. As we are talking about medical building, let me show you two medical pieces of equipment. It's an X-ray illuminator on the left side. Throughout the building we found all the different kind of X-ray illuminators. Depending on the size, they can be mounted on the wall, on the surface of the wall, which is the easier scenario. It only requires then probably some power outlet, some power supply. But in case of bigger pieces of illuminators, we have to place recessed illuminators. And it can also happen that it's not only an illuminator but a medical screen that you can see on the on the bottom right corner. And such medical screens are placed all around the operating rooms and patient care rooms. As you can imagine, you can review and the doctors can see different kind of different pieces of information on such screens, so they have to be routed and connected to the right server. They have to be connected to the necessary computer. It makes it a bit more complicated to have the right data outlets in the right positions. And some examples for pieces of equipment or casework furniture which is placed in front of the wall, and I think this is the most common example. So you would find office spaces in any kind of building. It doesn't have to be a medical building. On the screenshot, if you can see it, I show nurse station, and such a nurse station has lots of computers as well as screens, monitors, and obviously some printers and casework. So all these pieces of equipment had to be coordinated with the, for example, with the outlets which feed these pieces of equipment. So the challenge itself is that the partition walls are rather congested, not only in medical buildings but in other building types as well. So whatever I mentioned to you previously and much more than that, those all have to be coordinated and placed in the right location. But the extra challenge that we were given by the owner is that he wanted to reduce the change orders quite dramatically. Actually, he wanted to reach the zero number of change orders on this project. The other extra challenge, because we had two of them, was that we were introduced to this effort rather late. So the construction was well ongoing when we started our service, when we started to coordinate all these systems. So the challenge was to find out a workflow which will let us not only catching up with the construction, but getting ahead of it and creating valuable input for the design teams and for the construction team. So Vico Services is a process-oriented organization. So we developed a process for this challenge. Obviously we accepted the challenge because we like challenges. So we put together a workflow, a unique workflow, together with the best practices that we developed for this effort. And as we pretty much do everything in 3D, that is our starting deliverable, we decided to do this and accept this challenge with a 3D model as well. So we decided to build this detailed interior model in 3D and just place everything that we can think of. We collected all the available pieces of information from all the different contractors and designers. So we decided to take, for example, the electrical contract documents and just model the data and power outlets based on the contract documents. We did the same with the telecommunication. We did the same with the casework and the casework backings, for example. The fact that we did the majority of the modeling ourselves led to that we could reduce the meeting hours quite dramatically. So all these contractors, subcontractors, and designers didn't have to get together to coordinate their work. We did the hard part of coordinating, and based on code requirements and our own developed system priority structure, we basically pre-coordinated everything, and then we just had to have reoccurring weekly meetings with the dedicated team on site, and they had to validate our assumptions, or if there were some questions which were out of scope, out of our scope to answer those questions, they could answer, and we just adjusted the model accordingly. We also wanted to minimize the modeling effort as much as possible. On one hand, to save cost. On the other hand, as I mentioned, we were already delayed when we started the project, so we had to find out something to catch up with the progress. So we managed to reuse lots of the already existing data. As I mentioned, we built the structure and architecture model ourselves previously, so we just have to update it to meet with the current set of documents. We were participating in the above-head coordination, so we could reuse that data as well. And it led us to be able to catch up with and get ahead, finally, of the coordination. We put together a special, or not that special, in case of Vico services, but we put together a team setup, which meant a team of modeling experts who could be working on this pre-coordinating and modeling everything, and myself, who was embedded on site. I was the on-site project manager of this effort, and I was participating in the weekly coordination meeting with the owner, with the contractor, general contractor, and the subcontractors, validating the success of the successfully pre-coordinated model, and adjusting the model here and there when it was necessary. Then finally, we printed out 2D documents, and those documents were handed off not only to the subcontractors who are actually going to build these partition walls, but also to the nurses and doctors to be able to sign off on their final workspace. However, before printing out these 2D documents, we wanted to make sure that it's not only going to be a signature on the drawings, but they are going to be really satisfied with the workspace that we are putting together for them. So, as Holly mentioned, we introduced them the virtual environment. We introduced them the medical plaza in 3D views, and they could validate whether they like this or not, whether they need some modifications or not. So I will switch now to Archicad, because this effort was done in Archicad, and I think demonstration in the modeling application is going to be much more interesting than anything else. So I'm going to walk you through a couple of rooms, I think approximately 5 rooms. I'm going to show you 2 floors of this, out of these 4 floors, and show you some examples of what we did during the block coordination. So now you can see the second floor, and one room on the second floor. It's a patient care room, examination room, and let's see first of all how it looks like in 3D. I just turned to find, I turned off a wall so we can look into the room, but we can actually see in the room. Nothing special, I have to say. So we have a casework, the hand sanitizer, biohazard waste bin, a computer that is necessary in such a room, an examination table, also known as bed, and some other pieces of medical equipment. Note that on the walls you can also see the necessary power outlets, data outlets that goes together with the computer, as well as on the other wall which feeds this piece of medical equipment. So this is the 3D view that we quite often reviewed together on the weekly meetings, as well as introducing it to the end users. We not only have 3D views, but we also created 2D views, 2D elevation views. So let me show you a couple of these. You see the same thing as in the 3D view, the casework, the outlets, the waste bin, and the medical computer. on the north elevation, you can see the view of the medical equipment. On the east elevation, we have more things going on. So here is another hand sanitizer that I mentioned that the nurses and doctors would want to use quite frequently, and different kind of power and data supplies. What you may have recognized on the south elevation, let me go back to that, lots of dashed lines. And it is because, as I mentioned, we reused the data coming from the above head coordination. So we actually knew where the standpipes, where the vertical pipes are going to be built and going to be placed in the walls. It's quite important when we talk about coordinating and placing everything in the right location. If we review the same situation in 3D again, and if I turn off this wall to see inside of it, you can see that there is a pretty big diameter of waste pipe which goes from the third floor down to the first floor, crossing the second. If I get around it, it's probably more visible. We have some vent pipes and domestic water pipes feeding that sink. Obviously, we cannot really place heavy items on such a big waste pipe, nor electrical equipment around the domestic water pipes. The other beauty of building everything in 3D, and I think I will have a better example for that, but let me mention it here as well, is that we not only built the dedicated rooms which were actually coordinated, but also the neighboring rooms. So when we wanted to locate a power outlet on one of the walls that we coordinate, we actually knew where the other power outlet would go on the other side of the wall. So we could make it simple for the site team, and we could just align them to be able to faster, to be able to speed up their process. So if I go back to the elevation view again, this is the reason of having these center lines showing the actual piping systems in the wall. As I mentioned, I'm going to introduce not only the rooms themselves, but some modifications that were required either by the contractor, general contractor, or subs, or the nurses. And in this room, I can show you a nice example that the nurses asked us to modify. So when they reviewed all these rooms, and we had multiple patient rooms in the building, when they reviewed a few of them, they said that there are doctors who are right-handed and there are other doctors who are left-handed, and we didn't even think about it. And they said that some doctors prefer to stand on the right and the other doctors prefer to stand on the left. So their request was if we can just change the layout and turn this room, for example, to a left-handed room. Obviously, we could do this. It was not a big deal. So let me just show you what we did during coordination. It was this simple. So basically, with a few clicks, we could satisfy the end users and create a few rooms for them which were left-handed instead of right-handed. If we check the same scenario in the elevation view, as that is also automatically updated, you can see now that the north elevation has now the medical screens and the computer, while the south elevation has changed as well, and only that big piece of equipment is standing there. Let me go to another room and show you a different example. I think this example can be applied to any kind of building, because as I mentioned, it's an office space, and such office spaces you could find in any building type. There, for example, you have a reception. This is a nurse station. You could see that in one of my slides in my presentation already. So as I mentioned, we have lots of computers, screens, printers, and casework placed here. It doesn't seem to be complicated to coordinate it. However, surprisingly enough, we found many issues that we had to deal with. I'm going to show you one elevation only. This is going to be the east elevation of this location, and I'm going to show you two issues that we identified on this single piece of wall. As you can already see, here is a note added per meeting. So when our team modeled and pre-coordinated everything, they found that the specifications ask for a computer in this casework. So they placed the casework, but they were wondering where the power outlet and the data outlet can be to feed that piece of equipment. So they made some notes suggesting that we should place power and data outlet there, and the GC together with the owner could verify that it's a good assumption, good suggestion, and we definitely should place some power and data outlet there. As well as in case of this printer, you would think that a printer requires data outlet as well, just like power outlet, and we cannot really see anywhere around this printer. The reason for that is that we took the electrical drawings and modeled everything that we found on them, and actually in this area we found power and data outlet, but it was located wrong, so they wanted to place it behind the casework. If we follow the sequence, the construction sequence of placing a casework and versus building partition walls, we know that partition walls comes first. We place the outlets there, and only after that comes the casework. So it would have been quite a problem if the casework or if the outlets were placed behind the casework. So it would definitely have become a change order that we wanted to avoid. So the thing that we could do is just simply elevate it to the right elevation height. So it's not clashing any longer with the casework, and there is easy access to it above the printer. To finalize the 2D view, we just had to add some dimensions, and it was ready for the nurse's review. I have another example, however it's not from the second floor. I just copied one example aside the second floor from the first floor, because I think this is what the nurses enjoy the most. So this is X-ray, but let me show you in 3D rather. This is an X-ray room. You can find the examine table again. The X-ray machine, this is represented just simplified with boxes to show the actual space requirements. Note that in the above head we have the holding supporting structure of this heavy equipment. And as you probably know, such a room requires special equipment which is controlling the device, and it requires that the nurses are staying in the actual room, but it's not too healthy to have too many X-rays examinations, so they need a small space which is defended by a shield wall. It's not a simple wall, it has some metal in it, and it's quite thick, so it's not a simple wall. The nurses can stand behind these walls while the X-ray examination is ongoing. So what the nurses said that they would really enjoy if they want to see what they can actually see when the examination is ongoing. They want to have eye contact with the patient all the times. So it was easy to create a 3D view to them and just check what they would be seeing. And we found that not too much. Basically, they would see the leg or the foot of the patient, which is probably not enough. So they asked whether we can just make these windows a bit bigger, because it is not satisfying their needs. Obviously, as we are talking about a virtual environment. It was not a big deal for me to change it and make it bigger. But luckily enough, we were in time, and we could. I mean, the owner could order bigger examination windows, and they could be changed to create a better working environment for the nurses and the doctors. Obviously, if it was only recognized after the opening of the hospital or the medical plaza, it would have been way too late, and changing these windows would have cost much more, because these windows would have been already ordered and placed, and most likely for a few days by changing these windows in these not too simple partition walls, even the X-ray rooms would have been closed on. So a few examples from the first and second floor. Let me just jump up to the fourth floor for a second, and I think I will show you an operating room here. It was already in my presentation as well. I just want to introduce one thing that I mentioned on the second floor. So this is an operating room, lots of screens with the necessary data and power outlet, floor lighting, some whiteboard, other screens that go on the walls, the well-known X-ray illuminators, and on the other side of the room, all the necessary switches and thermostats which control the room. But you can probably see already on this view this is a door, and usually, as you could see on the other elevation views, the thermostats and other switches are placed rather close to the door, so when they enter the room they can control the room. For some reasons it is placed far from the door, and we have a good reason for that. If I go to the other room, I find that here is a OR panel, an operating room panel, and this controls all the electrical happenings in the operating room. And if I go back to my actual operating room, you can see that this is a recessed panel. It's quite a big panel, and would take almost the entire width of the partition wall. Therefore, there is no way that we could route the thermostats in that location. So those thermostats had to be moved a bit further from the door. If we check it in the elevation view, you can see this recessed panel here, as well as all the other well-known plumbing systems going through the room, through the partition of the room. And the last example that I'm going to show you is a recovery room. Holly mentioned that she thought that we only coordinated the walls behind the patients, but we did a bit more. But this was definitely one of our services as well, to coordinate what goes on the head walls and what we want to place on the head walls. The head wall is actually a piece of wall and equipment which carries lots of different medical equipment. We have the bed here, we have computers and different kind of screens. Actually, we have even a television on the wall, so the patient can recover. When the nurses and doctors again reviewed the elevation that we provided to them, they were not fully satisfied. However, we coordinated everything, and that was our first task, to coordinate everything. Second task was to satisfy the end users, and they found that, for example, the nurse calls, the exam lights, and wall phones were supposed to be placed next to the head wall, not on the head wall. So they asked us and the general contractor to change this setup and move all these pieces of equipment to the head wall, because that's much more useful for them. So that's about it in the application. Let me go back to the presentation for a second. We had the 3D views validated by all the subcontractors and designers, the GC and the owner, as well as the end users, the nurses and the doctors. And that's when it was time to print out the documents that we created, both the floor plan and the elevation view documents, and just have the sign off on them. You can see one sign off on this document with the latest change that they required. So the conclusion. We started out with aggressive targets. The fact of trying to reach the 0 change orders and joining the team by the construction was already ongoing. It made this project difficult. However, as I mentioned, we love challenges, so we took the challenge, and I think the keys to successfully fulfill the requirements was the workflow that we worked out, so building everything in 3D, taking every piece of information with us together with the contract documents and the RFIs which were ongoing in the field, and incorporating everything in the model, having it done with a team of expert modelers, and pre-coordinating everything based on the rules, the code requirements and the rules that we built up ourselves, the system priority structure, and also reusing the already existing data that helped a lot to reduce the duration and the cost effect. And finally, to validate the work environment not only by the engineers, but we definitely needed the input by the end users as well. So following this workflow, we managed to create a workspace for the end users which they really like. So just asking the owner this week if they have any change orders since the opening of the hospital, which was in 2009. So he confirmed that there are no wall partition wall related change orders, change order records. So we definitely succeeded in reaching the 0 change orders. And obviously it means that they could save quite a lot on not having change orders and not having to modify anything after opening the medical plaza, so they could spend that additional money on purchasing better equipment or fund exceptional care.